Okay, so in this particular problem of using for and next loop, we're going to look at a program that output all even numbers from 1 to 50. So let's do a recap of what is an even number first of all. So an even number is exactly divisible by 2. In fact, it means that if I'm testing 4 and I wish to prove that 4 is an even number, I apply the mode 2 with it. When I apply the mode 2 with it, it should give me a remainder of 0. This is the meaning of exactly divisible. So to test that a number is exactly divisible, in fact it is even number, what you can do, you can just do that number, num mode 2, it must be equal to 0. So here you can see that we can actually find out a relational operator for that particular problem. Now this particular problem requires us to do even numbers from 1 to 50, therefore 2 will be an even number, 4, 6, 8, it goes on like this. So if you have to test an even number, where you're inputting a given number, you will do if num mode 2 equals 0, then you're going to do a particular action, maybe output that number. Now use this if statement here and a for next loop, we can actually work out a pseudocode version for this particular program. So let's take a look to that now. So we'll use a for next loop for that. So it's going to do number 1 to 50 as such. So I do for the for keyword. I use a count variable, maybe my number. So I call it num. For num1 to 50. It means that my for loop will iterate from number 1 to 50, each time getting added with 1. Now, I'm not going to complicate the problem for now. So I'm just going to say, let us just print all numbers from 1 to 50. In that case, you're going to do output num. So here what it is doing, if you take a look, so this is your screen maybe where you're getting the output. So we start with number 1. We enter our loop body here. Now we output 1. Next, we go up. Number 1, num will be incremented by 1, which gives us 2. We enter the body for the for loop. It becomes 2. We go back again to the for loop 3. Now we're getting all numbers between 1 and 50, if you take a look. Now let us change this algorithm that we have right now to that of finding all even numbers. So we can just add an if statement here to test that num which is entering the loop. So for that we do if num mode 2 equals 0, then we output the number and then we put in an if. Let us observe what is happening. So let me clean this, my output screen, and then you're going to have num, which is here. So when num is 1, again this is my loop body, is 1 mode 2 equal 0 right now? The answer is no, because it's going to give us a remainder of 1, so it doesn't output that number. Now again we go and touch the for statement again. 1 will be changed to 2. Now we're going to have 2 mode 2. Now if you observe, 2 mode 2 is 0. That is, it is an even number. In this case we're going to output the number 2. In the same way for 3. Now 3 mode 2, here in fact it's 1. And here it's going to give us 1 again. Now it's not an even number. Again, to go up, we have 4 mod 2. Now in this case, this is going to be 0, then the number 4 is outputted. If you take a look, all the even numbers from 1 to 50 will be outputted in the following program. Thanks for watching and see you for the next problem. So welcome to your second problem, which concerns writing a program that will output how many even numbers there are between 1 and 10. If you take a look, the even numbers are 2, 4, 6, 8 and then 10. Remember, they are inclusive. In this case, since here we need to loop through number 1 and 10, my for loop will start with number 1 and it will end with number 10. Now you can use any count variable here, but for now I'm using num. Now in this particular problem, it's different to that of summing up. It's about counting. And when we're counting, we need to count. This is the first even number, second even number, third, fourth, and this one is fifth. So let's take a look how you're going to carry out this problem. So again, I will need a for loop for that, from 1 to 10. And to test if they are even numbers or odd, we use the same principle, num mod 2 equal 0. Then do something with it. Then and if. Now, in order to find out or output how many even numbers there are in this particular problem, we'll need to set a count variable. So for here, you can name it count even, or you can name it count. I have not executed the program yet, so I start with a count equal to 0. Now, if I find a even number, I will just do a counting statement with it. So count is equal to count plus 1. In the end, this can be n4 or next num, but for now I'm using n4, so output count. Or you can put a message, there are so many even numbers from 1 to 10. Now let us observe what will really happen using these particular code when they are executed. So first of all, we have count on this side. I'm going to write it. We have the count variable, which is equal to 0, and we have num in another memory location. This is 1. Now I'm going to write all my computation on this side. So for number 1 to 10, so first, this is my loop body again. So first, number mod 2, therefore 1 mod 2, this gives us 1. So the answer is no. So count will not be incremented, it remains 0. Now next, num becomes 2 because it goes up here. And in this case, num is incremented by 1, which gives us 2. Now 2 mod 2 in this case will be 0. Therefore, count is equal to count plus 1. So what is the current value of count? 0. So 0 plus 1, this will give us 1. We go up again. Now num is 3. Now 3 mod 2, that gives us 1 and not 0. So count will not be incremented. We increment num now again for going up the loop. We have 4 mod 2. 4 mod 2 is 0. You can take a look to other previous lessons I have discussed in the lesson of relational operators, the concept of modulus. In this case, since 4 is an even number, we're going to increment count by 1, so it becomes 2. Like this, from 1 to 10, each time we're going to compare the number, and we will stop at number 10. So this is your second problem. Hope you have understood this problem. We're going to look at the third problem now. Thanks for watching. In this particular problem, we are looking at inputting 5 numbers and how many numbers there are that are positive, or that are positive in fact. So out of those 5 numbers, how many they are positive? Here we have to input our number 5 times. In this case, if you take a look, we have to do it 5 times repeatedly. So among these numbers, let's say, how many of them is positive if I have inputted 5 numbers. In fact, you can say this is 1, this is 2. So basically it becomes a counting problem. So let us solve it step by step. So we need to input 5 numbers. So there must be a for loop for, let's put it I now as a count variable, 2 for I is equal to 1, 2, 5. Okay, next we need to input a number. Okay, so I'm inputting none. Now, if this number is positive, how do we test if a number is positive or negative? If you still remember, I've said using a number line, all numbers that are greater than 0 when we are doing decision, they are considered positive. In this case, if the number is greater than 0, then we can say it is positive. Okay, so let's take a look now. In order to find out how many of these numbers are positive, we need a count variable, and most of the count variables, they start with 0. So if the number is greater than 0, therefore it is positive, we can just do a counting. Count is equal to count plus 1. We do an nf, and then we do an n4. Now, if you observe here, all count initialization for 0 happens outside the for loop, and the output of the program is given outside the for loop. This is very important because when you identify errors in a given algorithm, you need to observe these, okay? So 1 to 5, and then we're inputting numbers. So it's very different. Sometimes students just write input I, but you can't input I here because I is already a count variable for the for loop. So remember that when we are inputting numbers, there should be a different variable that is computing that. Let's take a look to an example of driving this particular algorithm. So you have 2, minus 1, 2, 5, and then 0. So these are the numbers that are going to be inputted. So we start with a variable value I of 1, and count is currently 0. Okay, and again, these are the loop body. So we begin with count 0, I1. We input a number. So what is the first number? 2. Now we come here. Is 2 greater than 0? So here the number is 2. Is 2 greater than 0? Yes. In this case, we increment count because it is a positive number. So I'm just going to write down 1 for that. Next, we again go up for the loop. I will be 2 now, so the next number is minus 1. So I'm just going to cross out minus 1. So is minus 1 greater than 0? No, so count remains the same. Now the third number is 2. Now, when we compare 2 with 0, it becomes positive. So number is 2 again. When it is greater than 0, in this case, it's going to give us a count of 2, because 2 is a positive number. Same for 5, which will give us a count of 3 when it is executed. Like this, 0 is not greater than 0 because it is equal. Therefore, I'm going to have how many positive numbers in this case? 3. Now, this is a very classic problem of counting, where you have positivity to check, even or odd to check, and so on. We have other problems involving counting. For example, you may be given a particular problem to find out how many of them is between a particular range. For example, between 5 and 6, and just kind of, maybe we'll look at a fourth problem of the word when we are doing for loop next time. Thanks for watching.